Hello students, welcome back to my channel. So in today's video we'll discuss about Pythagoras theorem, which is one of the most important theorem for class 10 students. So let us start. So before talking about the Pythagoras theorem, let us first know what is a right angle triangle. What are the parts of a right angle triangle? So in a right angle triangle, we have one of the angle as 90 degree. So here this angle is 90 degree and the side opposite to 90 degree, that is this one, is known as the hypotenuse. Okay, so this one, the height is known as the perpendicular and the down one is the base. So this is a part of a right angle triangle. We have a hypotenuse, which is the longest side of a right angle triangle. Then we have a perpendicular and a base. What do I mean by the longest side or the largest side? Means if the sides are given, if hypotenuse is 13, then the other two sides has to be less than 13. It could be either 5 and the base could be either 2. So these two cannot be more than 13 because in a right angle triangle the measure of the hypotenuse is the longest. Okay, so with this let us start Pythagoras theorem. So this is the statement of Pythagoras theorem, that in a right triangle the square of hypotenuse, so you have a square of hypotenuse, is equal to the sum of the square of the other two sides. So there are three sides in a right angle triangle. So it says that the square of hypotenuse is equal to sum. Sum means plus of the square of the other two sides. So first let us draw the diagram. So this is a triangle ABC right angled at B. I hope you can see this triangle right angled at B. So if it is right angled at B, which is the hypotenuse? AC, the side opposite to this. So given a right triangle ABC right angled at B, we have to prove that hypotenuse square, so AC square, is equals to sum of the squares. Sum means plus of the square of the other two sides. What are the other two sides? AB and BC. So for this we have to do some construction. So construction will draw BD perpendicular to AC. So BD perpendicular to AC is drawn. Okay, so let us see how to prove. So you can see that here we need AC, AB and BC. And if we see this figure carefully, we have three triangles here. Here one triangle is ABC, the large triangle. Then we have two small triangles. This one ABD and BDC. So using these three triangle combination, we are going to prove this theorem. So let us start. So the diagram is given. So in triangle ABC, so first of all we'll take the bigger triangle ABC and triangle ABD and this smaller triangle. First we'll prove these two triangles similar. Once we prove this triangle are similar, then the sides will be proportional. Okay, so see here ABC and ADB each is 90 degrees. So ABC is 90 degree and AD, so this angle is also 90 degree. So ABC and each 90 degree, and angle A is common to both the triangles. So using AA similarity, these two triangles are proportional. So if these two triangles are proportional, so what happens? Their sides are, if the two triangles are similar, so their sides are proportional. Okay, so now what we'll do is, see from here we'll get now AB square, because when we cross multiply AB into AB will be AB square equals to AD into AC. So if you remember, what we have to prove was AC square equals to AB square plus BC square, correct? So from here AB square we got, right? So now we'll find out BC square. How? We'll see. So similarly, if we take triangle ABC and BDC, what we'll get? We'll see. Okay. So angle C is common. In ABC also we have angle C, and in BDC also we have angle C. Angle C is common, and triangle ABC and triangle BDC are 90 degree. So this triangle is also similar, okay, using AA similarity, and since this triangle are similar, the sides are proportional. So here again, when we cross multiply, we get BC into BC, BC square equals to DC into AC. Okay. Then we have equation 1, we have equation 2. We're gonna add both the equation. How? Left hand side should be added separately, right hand side should be added separately. So we had to prove again AC square equals to BC square plus AB square, right? So this was what we have to prove. So if you see here, we got AB square plus BC square. So this part is done. Now we just need to find AC. To get this, what we'll do is, if you see at the right hand side, we have AD into AC plus DC into AC. So from here we can take AC common. So once we take AC common, we are left with AD plus DC. Right? We are left with AD plus DC. So now if you see the figure, AD plus DC is what? AC. So we're gonna use that. So AB is equals to BC equals to AC square, but because AD plus DC is AC. So hence proved. So this was Pythagoras theorem. I hope everybody understood it. If there's any confusion, you can comment down in the comment section. And all the best for your exam. Prepare well. Thank you.